All right, quick video on using the basic rules of exponent. First off, let's start by just talking about what are those rules. Well, your basic rules look like this. If I've got something raised to a power and I raise it to another power, I can just say, well, that's the powers multiplied. If I've got two things with the same base raised to powers, I can just add those powers. And we've talked in class about why these are true, so I'm not going to go over that again. This is just a quick refresher. If I take some parentheses with multiple items in it and I raise it to a power, I can split that out and just raise everything in the parentheses to the same power. If I have a power and then the same base to a different power being divided, the simplification is just that I subtract those two powers. If I have a fractional power, 1 over some number m, that's the exact same thing as taking the mth root of that number. And of course, by extension, if I had n over m, I know that I can write that as x to the n to the 1 over m because I'm multiplying those. And so that means that I've got the mth root of x to the n. So that's a little useful way to separate those. And then finally, anything to a negative power does not make the number negative. What it does is it makes it the reciprocal of the positive power. So what do we do? What are we looking at when we say simplify an expression with exponents? Well, first of all, we want to get rid of parentheses whenever possible. So if you can get rid of parentheses right off the bat, that can be useful. Get rid of negative exponents. Whoops, get rid of negative exponents. And whether you do this before, if they're in the parentheses, then get rid of the negatives before you get rid of the parentheses. If they're outside, then get rid of the parentheses first to whatever extent you can. This is a bit of a judgment call and requires practice. Stack and simplify like bases. And I'll explain what I mean by stack when we get there. But if you've got x to the some power on top of a fraction and x to some power on the bottom of a fraction, stack them, put them over each other because they're the same base, which means that they'll simplify together somehow. And so let's do some quick examples. The first example will be 6x to the fourth y to the sixth cubed. Well, this is get rid of parentheses by having cubed on each of the things. And by the way, a mistake I see a lot, don't forget it's 6 cubed. And then I'm going to multiply x to the 4 times 3 and y to the 6 times 3. And then writing that out, 6 cubed is, gosh, off the top of my head, I don't remember. So I'm going to leave it as 6 cubed. You could grab your calculator. 36 times 6, 180. 216, if I'm doing that right in my head, maybe. X to the 12th, y to the 18. Okay, next example, 18 c cubed over negative 3c squared. Now, this is a good example. This one you're probably like, yeah, that's obvious. But when I say stack, take things that are alike and stack them on top of each other. And the reason is because now I know that I'm going to simplify that and I'm going to simplify that. I know that 18 divided by 3 is 6, so that's negative 6. C cubed over c squared, well, my shortcut is c to the 3 minus 2. This becomes negative 6c. And remember to circle my answers so that whoever's looking at them can find. Okay, you notice they're getting slightly more complicated as we go along. 22y to the 6 z to the 8th over 2y z to the negative 7. So what do I do first? Do I stack? Do I get rid of negatives? In this case, I'm going to go ahead and stack. I got 22 over 2. I've got y to the 6 over y, and I've got z to the 8th over z to the negative 7. So the first couple are obvious. 22 divided by 2 is 11. Y to the 6 divided by y. Well, if I think about it, that's the same as y to the 1. It's just we don't write the 1. And so that becomes y to the 5th. Now, I could do one of two things here. I could either get rid of the negative exponent and make this z to the 8th times z to the 7th, or I could just say, well, this is z to the 8th minus negative 7. Notice they're both going to end up being the same thing. This is 8 plus 7. This is 8 plus 7. So either way, you get 11y to the 5th, z to the 15, and boom, there's my final answer. Okay, let's do a fraction with a negative power. I know that the negative power says take the reciprocal. Well, that means I could just flip this over. I don't have to go 1 over the fraction, which is more complicated. Instead, I take the reciprocal, and now it's to a positive 3, and now everything inside gets raised to the third power. So y cubed over x squared cubed, and then that becomes 2 times 3. So this is y cubed over x to the 6. There's my answer. Let's see, what do I want to do next? Let's do this one. Let's do negative 2x squared y to the negative 4th to the negative 2. So what I'm going to do on this is I'm going to do inside the parentheses first. I'm going to get rid of that negative on the y and put this down here. And now there's nothing I can simplify in the parentheses, so I'm going to do the negative on the outside, which means the reciprocal of what's inside. And then this is all squared. And then I'm going to square each thing. So on top, I've got y squared. On the bottom, I have negative 2x squared squared. And of course, negative 2 squared is 4, x squared squared is x to the 4th, and nothing simplifies. I'm done. I circle my answer. And let's do the final but one example. Let's do x squared over y cubed to the 1/3. Well, there's a couple ways we could look at this. This is the cube root, or we can multiply. So I could either say this is x squared times 1/3 divided by y cubed times 1/3, which is x to the 2/3 over y. Or I could say this is the cube root of x squared on top and the cube root of y cubed on bottom. But notice that the cube root of y cubed is just y, so an alternative way to write this in a more simplified form. These are both acceptable. It really just depends on what you're trying to do. And finally, let's look at one with a number, 9 to the 1/2 squared. Well, obviously, I could just say this is 9 to the 1/2 times 2, which is 9 to the 1, which is 9. Okay, fair enough. But if I do it in a different order, what if I said, oh, well, 1/2 means square root, but I know that the square root of 9 is plus or minus 3. I'm just going to, let's just go with the positive root right for now. So I know that that's 3 squared, which is 9. Notice I get to the same place either way. So now let's talk very quickly about simplifying 8 to the negative 1/3. Well, the negative is makes it the reciprocal. So this is 1 over 8 to the 1/3. Yeah, you could say it's 1/8 to the 1/3. But of course, that's 1 to the 1/3 over 8 to the 1/3, and 1 to any power is just 1. So I'm back to that 8 to the 1/3. Now, what do I do with this? Do I just stop here? Well, here's where I recognize that 8 is a power of 2. And being able to write numbers as the smallest possible power, the prime power, can be helpful because now what I have is 2 cubed to the 1/3. Well, hey, look at that. 3 times 1/3 is 1. 8 to the negative 1/3 is actually 1/2. All right. One more quick example, and then I will honestly for sure be done. Let's look at the cube root of x squared times the 6th root of x to the 4th, all to the negative 3. I know this looks insane, but this is a good example of going the other direction. The cube root, I want to write this as x to the 2/3. Because this is x squared to the 1/3. In fact, here, let me take that extra step. This is x squared to the 1/3. This is x to the 4th to the 1/6. And we'll leave that as negative 3 for now. X to the 2/3 times x to the 4/6. You may have already noticed that 4/6 and 2/3 are the same number, just not simplified. So 2/3 plus 2/3, this is x, well, let's write it out, to the 2/3 plus 2/3, all to the negative 3. Running out of room, I'm going to jump to the next page. So I get x to the 4/3 to the negative 3. This becomes 1 over x to the 4/3 to the positive 3. And when I multiply these together, I get 1 over x to the 4th. Notice much, much simpler than that crazy one that we started with, where we just had all these roots and powers and negatives, and instead that whole thing boils down to 1 over x to the 4th power. Okay, thanks for watching.